equal 5 longest palindromic substring. So why are we going to solve this problem? Because this problem is really easy to understand. It is just one sentence. We are giving a string S and we're going to return the longest palindromic substring in S. So this means for such kind of problem, it's really easy to appear in a real interview because the description is so short. The interviewer just tell you one sentence and then let you solve a problem. He doesn't need to explain too much about it, and then you have to solve it by yourself. So I'm gonna use two ways. So the first method is I'm gonna call it setter spreading. So it's gonna spread from the setter. Yeah. So the idea is that this is our string S, and we're gonna take some character. For example, this character. For example, if it is A, and then we're going to spread it to both sides. If this is B, we're going to continue to spread. If this is C, we're going to continue to spread. So this means for each of the character, for example, this character B in the middle, we just need to use O(n) time. And how many characters? There are n times. So the time complexity is going to be O(n) squared. So this means that definitely we can solve the problem. So this is going to be the first method. The second method is dynamic programming. And the idea is similar. But for the setter spreading, it's really difficult to think about it. You have to solve some similar problems, then you might think about how to solve it. But for DP, it is just normal. But the coding may be a little bit harder. So for the DP idea is that if we can solve, this is our string S. If we can solve a sub-problem, now we're gonna check if we can solve the whole problem. So for example, this is our sub-problem. It is here. So this is A, B, and B. Yeah. So if we know that BAB is a substring, what about the other characters at the left and the right side? For example, this may be a C, and here may be a C. We just need to check if this is C equal to this is C. So this is the dynamic programming idea. So in order to solve the problem, we're gonna solve the sub-problem first. Yeah. If this is C, we're gonna check, oh, the length is 5, and this is gonna be the final substring. So if this is C and this is D, yeah, we are sure they are not equal, and we will not solve the problem. But for the sub-problem, definitely, because we've already solved it. We already know we have a BAB, so we're going to return the final result, which is going to be BAB. Yeah. So this is the whole idea. Now we're going to analyze why we cannot use this brute force to solve the problem. Yeah. Because for the brute force, definitely we're going to use 2 for loops, and then we can find a substrate, for example, BAB. For finding the BAB, we already used the O(n) squared because we're gonna use the 2 for loops to check the substring, and then we're gonna use we're gonna check if this BAB is a palindromic string. It's gonna be another n time, so it means n cubic. Definitely, it didn't work. So this is why we're gonna use some clever ways. The first is the center spreading, and the second is the dynamic programming. So now what left behind is we just need to finish the coding. So the center spreading is always easier, so let's just try the center spreading first. So we're gonna set 2 indices I and j, and then we're gonna spread it. So I gonna always be less than or equal to j, so this is normal while we are setting the indices of I and j. I gonna be more than or equal to 0, and j gonna less than n, and n gonna be the length of the string, and the result going to be an empty string. Yeah. And we're going to check if si equal to sj, and then we're going to continue to spread. So I going to be -1, and j going to plus equal to 1, and then we're going to return the final string. So it's going to be I plus 1 to j. So let me just explain why it is I plus 1 to j. So for example, this is here. We are spread from this character B. B is okay, and then we're gonna spread AA. It is okay. No, it is still okay as I equal to Sj, and we're gonna spread to B and D. They are not equal. We're gonna go out of the while loop. But this is I. It is pointed to this character B, and this is J. It is pointed to the character D. But we need to return ABA, so this is why it is I plus 1, and here this is j. Actually, it goes to j minus 1. Yeah. So this is why we are writing like this. Now we just need to get the final result. So for I in range n, so this is just like a brute force. We're gonna check all the characters one by one, and then we're going to use the setter spreading to find the final result. We're going to use a maximum of the result with the helper function. The first one going to be I and I. So this is for the first case. It can be a character B, or it can be some cases like AA. We're going to spread from this AA. This is another case. So this is a Y. We're going to use another helper function. It's going to be I to I plus 1. And this maximum function, it can put many parameters inside, but currently we are comparing the string. It is not for checking if C is more than B or something. It is checking the length of the string. So this means we need a lambda function. Here we're going to use K going to equal to length. So this is a simplified version of lambda function. This means we're going to compare the length of all those strings, and finally we're going to return the string itself. So this K is just a lambda function. Yeah. Now we're going to return the final result. Now let me just run it and check if it works. Now as you can see it works. Let me just submit it. Yeah, as you can see it works, and it's pretty fast, but the time complexity is O squared. And the space complexity is O1, and because we didn't use any actual space. So this is why this is a really good method, but sometimes it's really hard to think about it. Why you can think about it, it's gonna spread from the middle. Maybe it's a little bit of thinking. You need to think about it first. Yeah. So here, as I said before, this is a lambda function. This K equal to length is just a simplified version. Maybe you can write it like this: K gonna equal to lambda x. We're gonna compare the length of the x. So this is the complete version of the lambda function. Yeah, as you can see, it works. Now let me just submit it to prove it works. Yeah, but normally we want to simplify it. So this means we can still delete all those areas. K gonna equal to the length. This is just a simplified version. It just means the same thing. So it still works. So this is why I write it like this. Yeah, we're gonna simplify the code a little bit. Now let's just use another way, which is dynamic programming, because sometimes the interviewer don't like this solution. Yeah, maybe you were asked to solve it by using dynamic programming, so now you have to solve it by using DP. Yeah, so for the DP, I'm gonna prepare N and the result. N gonna be length of the string, and the result gonna be an empty string. The idea is for dynamic programming. It is the reverse of center spreading. It is always a check from the both side, left side and the right side. In case of the subproblem has already been solved, we just need to check if we can solve the whole problem. Yeah. We're going to prepare a function f. This is the DP table. It's going to be false times n for anything in reason n. We're going to prepare a 2D table, 2D DP table, because this is a substring. We need to check something. This is the string. We need to check something from I to j. And how can we find it? We're going to use a DP table, 2D array DP table. Now we can solve it directly. J gonna always be bigger. So for j in range n and for I in range j plus 1. This is because we're gonna check something like fj and j. So definitely this is I. The maximum of I is j, because here is j plus 1. The maximum of I is j. Yeah, so for example, this is the j. Actually, this is for example n minus 1, and this is I. We're gonna check all the cases. We're gonna check all the cases which is possible. Which one is possible? We're gonna check the maximum value. This is the dynamic programming. We also include the case of fj and j. So this is why it is j plus 1, and I gonna always be less than and equal to j. So this is our setting for the dynamic programming, and we're gonna check all the cases and we're gonna find the solution. Yeah. So while we are checking the whole problem, so for example, this is I to j. If this subproblem has already been solved, Now we just need to check this problem. This means the time complexity going to be O(n) squared instead of cubic. Yeah. So the condition is that we need to check if Si equal to Sj. Otherwise, we don't need to check it. Yeah. If this is equal, and we still need to check the subproblems. We want to check if the subproblem has already been solved or not. So if the subproblem is like something like ABA, yeah. So this is I and J. For example, this is I and J. If Si equal to Sj, if the length of the string is 3, definitely it is okay. We've already solved it. If the length is 1, it is also okay. If the length is 2, it is also okay. Yeah, because they are equal, definitely. So this means we need to control the length. The length is controlled by J minus I. So J minus I gonna less than or equal to 2. So this means, yeah, definitely this problem has already been solved. So this is one case. If the length is 3, like this case, and this case. Yeah. So another case is that we're gonna really check the subproblems. So the subproblem is gonna be F. So this is I to J. So the subproblem is going to be I plus 1 to J minus 1. If the subproblem solved, it is also okay. Yeah, but here it is OR, not ADD. Yeah. So this is one case. If the length of the string is less than or equal to 3, it is true. Another case is that if it is more than 3, but the subproblem is true, so definitely our whole problem is also true. Yeah. Now we can set the DP table. So Fi to J. First of all, we're gonna set it to true. So this means for this subproblem, we've already been solved. We've already updated it to true. Now we're gonna, so for example, this is I to J, this is I to J. This subproblem we've already been set. It's gonna be true. Now we can check these problems. Yeah, if they are equal and this subproblem is true, so definitely our whole problem is gonna be true. Now we can update the final result. Similarly, it's gonna be result here gonna be I to J plus 1 because it is going from I to J. And here I'm going to prepare K going to be the length because we're going to check the final characters instead of a number. So we're going to return the final result. Now let me just run it to check if it works. As you can see, it works. Now let me just submit it. Yeah, as you can see, it works, and the time and the space complexity are both O(n) squared. As you can see, this is the DP table, O(n) squared, and this is the 2 for loops. So the time complexity is going to be O(n) squared. So I prefer to use the dynamic programming because it can be used in a lot of cases of Leetcode problems. Definitely, if you learn this one, definitely you can use it to solve many other problems. But for the center spreading, maybe there are not so many problems, but it is also a good solution. I think that's all about it. And thanks for watching. See you next time.